Maybe you're already an expert on this and know what the debate is all about. Models have been saying that the Atlantic Meridional overturning circulation is slowing down and there is a lack of warming or even cooling in the North Atlantic over here, where the North Atlantic deep water forms in the Greenland, Iceland, Norwegian Sea, Labrador Sea, and so on. And there's been some analysis about whether that lack of warming or cooling has come because there is reduced transport of warm water, or is there more transport pulling out the Atlantic water into the Arctic, and there is some evidence that there is an Atlanticization of the Arctic and so on and so forth. So here is an interesting paper that raises some doubts about this whole thing. It says Florida current transport observations reveal 4 decades of steady state. Again, you may already know, but Florida current is basically this path which goes into the Gulf of Mexico and comes out between Florida and Cuba, hugs the coast and peels off, separates from the boundary and goes off into the North Atlantic and so on. The potential weakening of the Atlantic Meridional overturning circulation, or AMOC, in response to anthropogenic forcing suggested by climate models is at the forefront of scientific debate. And a horrible headline came very recently saying maybe the Gulf Stream will collapse by 2025. The media jumps on these things without really understanding, they are not experts, but they also love the shocking headlines, sometimes a little too much. So that kind of nonsense has to be avoided, right? So a key AMOC component, the Florida current, has been measured using submarine cables between Florida and the Bahamas at 27 north nearly continuously since 1982. There's a little gap. A decrease in the Florida current strength could be indicative of the AMOC weakening. Here, we reassessed the motion-induced voltages measured I have a bug measured on a submarine cable and re-evaluate the overall trend in the inferred FC transport. We find that the cable record beginning in 2000 requires a correction for the secular change in the geomagnetic field. Okay, so Florida current is flowing over the cable, which is approximately across the current. When water flows with salinity and so on, there is a voltage change that can be detected, but that is also related to the magnetic field, so that has to be corrected for, which they do. We find that the cable record beginning in 2000 requires a correction for the secular change in the geomagnetic field. This correction removes a spurious trend in the record, revealing that the FC Florida current has remained remarkably stable. The recomputed AMOC estimates at 26.5 north with another dataset result in a significantly weaker negative trend than that which is apparent in the AMOC time series obtained with the uncorrected FC transport. So there have been data processing issues because they missed correction that was needed. Okay, so this is the point we're talking about, and here is a figure of the cable. So the cable is sitting right across between the Grand Bahama and West Palm Beach in Florida. Perfect spot to measure the Florida current that's going through in here. So that's the submarine telephone cable. There are also dropsondes, ADCPs, so lowered acoustic Doppler current profilers, expendable bathythermographs at 27 north, bottom pressure recorders, satellite altimetry data. So they use all these data as over the common periods to ensure that their analysis is correct and within error bars and so on. And the main conclusion, as we will see, is that the Florida current has remained stable. So originating as waters from the Gulf of Mexico loop current that enter the western straits of Florida, the Florida current is constrained by the relatively shallow bathymetry of less than 800 meter depth between the Florida Peninsula, Cuba, and the Bahamas before entering the open North Atlantic and becoming the Gulf Stream over here. This strong upper ocean flow, where the surface currents can reach velocities of 2 meters per second, represents the beginning of and the swiftest part of the Gulf Stream system. 2 meters per second is a very, very rapid current for ocean, where things basically move at order centimeter per second, right? The FC carries approximately 32 sphere ribs of warm, that is 32 million meter cube per second of water, and salty tropical waters northward. I didn't say it correctly. The FC carries approximately 32 sphere ribs of warm and salty tropical waters northward, and plays an important role in, I didn't turn on the fan, it's very warm, in the regional and global climate systems. Boosted by western boundary intensification, the FC provides most of the northward volume and heat transport in the subtropical North Atlantic, and accounts for bulk of both the upper limb of the Atlantic meridional overturning circulation and the western boundary component of the subtropical gyre circulation. Therefore, observing and investigating the variability of the FC is of particular importance for detecting and better understanding changes in the Earth's climate system, as well as for interpreting regional variations in weather, sea level, and ecosystems. So, deep water forms, this blue branch is the deeper part of the western boundary, AMOC, global conveyor belt, etc., which goes into the Indian Ocean and the Pacific, comes out here through the Indonesian seas, mixes with the Indian upwell water and back to where the waters sink, and there are also deep water formation sites here in the Ross Sea, Weddell Sea, and so on. So this is a very nice location where the narrow constrained current can help a lot with these things. So here is the good figure that I am skipping a lot of figures. The northward transport of the Atlantic meridional overturning circulation, estimated from measurements collected at the rapid observing array at approximately 26.5 degree north. The seasonal cycle was removed and the residual time series were low pass filtered using a 2-year cutoff window. The blue curve and the blue bold line, red curve and the red bold line, show the AMOC time series as linear trends computed with Florida current transport not corrected and then corrected. Okay, so you can basically, the main message, if you look at AMOC and sphere ribs, if you don't correct for FC, then there is an implied transport of 1.3 plus minus 0.7 sphere ribs per decade as a slowdown. But once you correct for the Earth's magnetic field, that trend is greatly reduced. So we are obviously getting results from the model, and we're excited that they are consistent with the cooling in the North Atlantic, and then over interpreting things in terms of what is happening to AMOC and what will happen into the future in the coming decades and centuries. So this data constraint, data-based transport estimation, give us a reality check that says we should be very careful about how we interpret the model data. There is growing scientific interest in how large-scale ocean circulation is changing or will change in the future in response to anthropogenic forcing. Give me a second, this is really warm. Let me turn on the fan. In Mumbai, we have something called October heat. After the monsoon ends, suddenly things warm up because sun is still heading south, and we are in fall. We don't have strong winter, so some parts get very hot again. But now this is extending into November as well, because I am now recording in the first week of November, 7th of November, and it's quite warm and humid. Okay, so let me come back to reading this then. Particular attention is paid to the potential decline of AMOC fueled by the results based on state-of-the-art climate models and proxy data constructions. Although solid observational evidence is still lacking, as direct observations of the AMOC are very short compared to the climate timescale, so 2004 to 2022. Some studies have used relatively small and often marginally significant trends in observational data as support for the notion of AMOC slowdown or even collapse. This is what I mentioned before about 2025 claim. Some conclusions based on observational products are oftentimes made without detailed consideration of how the raw data were processed. Arguments about the robustness of tendencies in observational data product usually rely only on statistical significance, yet it is important to realize that an inherent nature of observational record is that they may be subject to spurious drifts and biases caused by instrumentation and data processing issues. As a result, routine calibration, re-evaluation and correction of observational data records, sometimes years after the initial data were released, is an integral and inevitable part of any long-term observational program. Therefore, small and marginally significant in the statistical sense, small and marginally significant tendencies in data products should be treated with caution in any analysis of long-term changes. You should appreciate the inherent difficulty of the entire global thermohaline circulation. It's a very complex system with all kinds of eddies, recirculations. No doubt deep water formation happens and it flows south. No doubt it mixes with the bottom waters, deep waters formed here. No doubt it inundates the Indian Ocean and the Pacific Oceans. No doubt this whole loop exists, but to compute transports, you can see it's going to be a challenge. So the cable offers excellent way, because this is part of the AMOC is nicely constrained geographically and topographically, and cable data exists to provide some reality check, right? So in this study, we reassessed the 40-year record of the FC volume transport inferred from the motion-induced voltages measured on submarine telecommunication cables in the Florida Straits since 1982. The cable record constitutes the longest observational record of a boundary current in existence. Therefore, these cable observations, together with regular cable calibration cruises that directly measure the FC volume transport and water mass properties, provide a unique and invaluable data set to study climate variability in the North Atlantic on decadal timescales. Because the FC is the major contributor to the northward transport of both the upper limb of the AMOC, the warm salty part, and the subtropical gyre circulation, so there is a wind-driven western boundary intensification which adds to it. It is reasonable to assume, reasonable to expect that on sufficiently long time scales, a Florida current decline would indicate a slowdown in the AMOC and or the gyre circulation. So you have to be sure which component is slowing down. It should also be recalled that not all the western boundary flow is constrained in the FC. A small but highly variable part of this flow is carried by the Antilles current, which goes on the eastern side of the Caribbean chains and comes out just to avoids the Gulf of Mexico route. The long history of cable measurements in Florida Straits involved contributions from several generations of scientists. This has resulted in some differences in the processing methods of raw voltage during 1982 to 1998 and 2000 to 2023 period. So there are some details here about why EMF correction is needed. We focused our attention on the impact of secular changes in the geomagnetic field on motion-induced voltages measured by the cable, which the earlier part of the record was explicitly corrected for. So we could not re-examine 1982 to 1998 raw voltage as part of it had been lost. The small negative trend in the FC transport record is associated only with the 2000 to 2023 portion of the time series. The 1982 to 1998 transports have no meaningful trend. Since 2000, high-frequency geomagnetic signals have been effectively removed by applying a 3-day low-pass filter, so there is some methodology. So the length of the cable record continues to grow. Correcting it for secular EMF changes is crucial to get a real handle on this trend. The 2000 to 2023 cable record was reprocessed by first correcting the cable voltages for the secular changes in the EMF and then recalibrating the FC transports using ship section data. The corrected FC transport series is made freely available, so you can go check it out. So it appears that FC has remained remarkably stable over the 40 years with all this nice, detailed, robust analysis of the transports, reanalysis or reprocessing of the transports. Nearly continuous observations of 40 years show a remarkably stable Florida current. Furthermore, change in the Florida current cable transports necessitates a revision of the AMOC transports at 26.5 degree north since 2004, derived from the rapid array, which was also meant to put the to measure AMOC. I think it was I'm going to forget the name, Joachim Maratska and another American scientist. The use of the corrected FC transport time series reduces the negative trend in AMOC from 2004 to 2022 by about 40% and makes it only marginally significant in a statistical sense. The results then indicate that if climate models are correct, that AMOC is slowing down or will soon slow down. This slowdown has not yet been reflected in the FC and the AMOC transports, or the observational records are still too short to detect it with confidence. So we have to keep that in mind, that we are not saying models are wrong, we are just saying that this period of available observation data does not confirm the model's simulation of a slowdown of AMOC. This is in accord with other observation-based studies. Nevertheless, the likelihood of a future AMOC slowdown and the importance of both the FC and the AMOC in the regional and global climate variability emphasizes the value of sustained observations in the Florida Straits and in the subtropical North Atlantic at 26.5 degree north. The existing records are just starting to resolve decadal scale signals relevant to climate variability. Continued observations are thus necessary for detection and mechanistic understanding of climate-related changes and for validating and improving ocean and climate models. In the models, there is lots of issues that people have looked at. The mixing in the ocean models can produce remarkably different results in integrated transports. So models do all the currents, deep water formation, and global circulation in a global coupled climate model, and then you are diagnosing AMOC out of that by zonally integrating, looking for meridional transports, remembering that there are large number of eddies that Susan, what's her name, from Duke University, now she's moved somewhere else, that keeps looking at. So it's not a very simple circulation, so it's a diagnostic, and nonetheless we have things to do, we have things to explain and understand why observations are not showing a slowdown in this 40-year record, but models are, and how that is related to the cooling that we see in the North Atlantic at the tip of Greenland, between Iceland, Greenland, for example, and so on. Okay, so just keep this observational constraint in mind when you read about news items that keep saying Gulf Stream is going to collapse and so on. Always seek reality from papers, experts, whatever. Okay, see you in the next topic.